In today's world, artificial intelligence is more than just a trending topic. It's your path to a brighter, more meaningful future. If you're here watching this, you know deep down that you're destined for something extraordinary. Introducing the AI A to Z course, your comprehensive roadmap to mastering the entire spectrum of artificial intelligence. This is not just another course, it's an immersive journey into the world of AI, and here's what you will learn. Master the ins and outs of Q-Learning, a foundational AI system by building an AI that can land on the moon. Delve into neural networks while training an AI to play Pac-Man using only visual input just like a human would. Go even further with A3C by teaching an AI how to fight Kung Fu. And finally, learn all about transformers, large language models, and gain hands-on experience building conversational agents with tools like ChatGPT. The clock is ticking, AI technology is accelerating, and this is your chance to be a part of this revolution. So why wait? This isn't just a course, it's your launchpad to a rewarding and fulfilling career in AI. Take the step, enroll today, and let's turn your dreams into your everyday reality. Hello and welcome to the course on Artificial Intelligence A to Z. My name is Kirill Ermenko, and on behalf of Adlan de Ponteves, the co-instructor on this course, I'd like to welcome you into this amazing adventure that we're about to start. And what's up with this timer? Well, the reason for this timer is this is my third time recording this tutorial, and I get so excited about these things, and it just goes over, blows over 10 minutes or 20 minutes. So I decided to limit myself to 5 minutes to get you excited about this course and why it's the best time to be in AI. So let's dive into it. We've got 4.5 minutes left. Why AI? Well, we've all heard about applications of artificial intelligence that are popping up around us. Self-driving cars, medicine, heavy machinery, customer service, the list just keeps going on and on and on. But why right now? Why not 10 years ago or not 10 years later? Well, the answer is hidden in this curve, which is called Moore's Law. It was originally identified in 1965 by Gordon Moore, and what it says is that the power of the average computer, in very simple terms, the power of the average computer that you can buy for $1,000 will double every 18 to 24 months. And that's been, as you can see, the law has held constant through good times and bad, war and peace, and recession, depressions. Nothing stops this curve. And we've already surpassed the brain of an insect for an average computer that you can buy for $1,000. We're sitting at about the speed, the processing power of the brain of a rat. By 2025, we'll be at the brain of a human. As you can see, it's exponentially growing. And so this is a great time to be in artificial intelligence. It's just going to be doubling. The power is going to be doubling every time. All right, 3 minutes. So some of my favorite examples are related to games like chess and Go. So in 1997, DeepMind was the first computer to beat Garry Kasparov in chess. It was a huge thing. It was like one of the most broadcasted chess games on the planet ever, and at the same time, and so that was considered an impossible feat. Right now, on any phone, you can install an app with chess, which no human player will ever beat because computers are that good now. You just cannot beat a computer in chess if you put on the hardest setting. And then, just recently, in March 2016, a computer won against the 18 world champion of the game of Go, Lee Sedol. Again, considered an impossible feat. Even at the start of the match, it was considered to be impossible, that it's only going to happen 10 years from then. But it happened. And by the way, if you'd find out a bit more about the game of Go, it's very, very exciting, very interesting. It's got 40 million players, 3,000-year-old game, very popular in China, Japan, and Korea. And it's much more complex than chess. So there's many more possible combinations. So again, something that was considered impossible is happening, and it's happening now, and much earlier than its time. So how are we going for time? 1 minute, 52 seconds. So that's what you'll see from this course. You'll see that we're using games to train AI. Why are we doing that? Because games are a confined environment where if we can beat a game using an artificial intelligence, then we can use the same principles to apply to business. And that's the exact same thing that the team at Google DeepMind, who created AlphaGo, who won against Lee Sedol, that's exactly what they did. They applied artificial intelligence to Google's warehouse to control the air cooling And what they found is this is the electricity bill, electricity consumption. You can see like it's going like this. As soon as they switch on the AI, bam, goes down, and then they switch it back off, goes up. They were able to save 40% on their electricity bill, and I have 1 minute left. 40%. So you can find the full article on the DeepMind blog. That is insane. Imagine that for a company of Google's scale, which has millions and millions of servers. So there you go. That's your connection between applying artificial intelligence in games and applying it to business. Very, very closely related, and that's what you will be able to do after this course. And finally, one of my favorite blogs, waitbutwhy.com. Check it out. Amazing blog by Tim Urban. This is how he describes the situation we're in. This is us and technological progress. We're sitting here. This is what it looks like. It looks very, very linear, but because it's an exponential, boom, this is what's going to happen in the next years. And there's very strong evidence from the things we're seeing to suggest that we're sitting right over here on the kink of the curve. And that, my friends, in short, is why it's so exciting to be alive right now, why it's so exciting to be and get into and be in the space of artificial intelligence, because the power you'll have, the applications that you will be able to create, or the ways you'll be able to apply it, is going to be intense and insane. And I can't wait to see you on the first tutorial of this course. Let's get this started. Back to the course on artificial intelligence. I hope you're excited about today's tutorial because we are taking our very first step into the world of AI. And today we're talking about reinforcement learning. It's a very important tutorial because it will underpin everything else that's going to be happening in this course. So let's get started. Here we've got a little maze, and this maze is our representation of an environment. And that's what we're going to be dealing with in this course. We're going to be dealing with certain environments in which our artificial intelligence is going to be performing, is going to be taking actions, is going to be looking to beat these environments, going to be looking to win in these environments. And here we've got an agent. The agent is our artificial intelligence. That's the person, or that's the mind that's going to be navigating these environments and learning from the feedback that the environments are going to be giving it in order to perform certain actions. And so the way it works is the agent performs certain actions in this environment, and as a result, the state in which it is in will change. So it might be further or closer, or more to the left, more to the right. It might have a certain other parameters that describe its state, and those parameters are going to change. So the state is going to change because of the action it takes, and it will also get rewards based on the action. So every time it takes an action, the state will change and it'll get a reward. Now, bear in mind, sometimes it might happen that it won't change the state. The action won't change the state, or there won't be a reward for taking that action in that certain state it was in. But nevertheless, the agent is going to keep doing that. It's going to be taking actions, changing the state, getting rewards, taking actions, changing the state, and getting rewards. And by doing that process, it's going to be learning about the environment. It's going to be exploring the environment, understanding what actions lead to good rewards and favorable states, and what actions lead to bad rewards and unfavorable states. And this is a very simplistic representation of a very global problem. So if you think about it, environments actually don't have to be just mazes. It's not just about getting out of a maze or finding a treasure in a maze. An environment can be pretty much anything in life. So imagine you waking up in the morning and cooking an omelet. So in order to make that omelet, you need to go through certain steps. You need to get the salt, get the eggs, get the frying pan, switch the fire on, and so on. And it does sound like a routine, mundane thing, but it's become routine because you've done it so many times. But in reality, it's an environment where you're performing certain actions. You're putting the fire on, you're putting the frying pan on the fire, you're putting all the eggs into the frying pan, and you're putting some salt on the eggs, and you're turning them over, and so on. So as you can see, there are certain actions which you're taking in certain states, and those actions lead to certain other states and sometimes rewards. So for instance, when you put the fire on and you wait, you're taking the action of wait too long, and then you put the eggs into the frying pan, the reward is going to be very negative. It's all going to burn. On the other hand, if you do all the correct actions in the correct times, so it's also very important to understand that actions should be taken at the correct points in time. So for instance, putting the salt in the frying pan before you put the eggs in might not be the best idea. You might want to take that action of putting the salt into the frying pan
after the eggs are in there. So in a different state. So it's important to remember that. And at the same time, so if you take all the correct actions in the correct order, in the correct states, your final reward could be that you get an omelet which you can eat. And so that's a very basic activity in your life. But if you think about it, it is actually an environment, and you are the agent going through this environment and performing tasks. You don't really need to learn anything because you already know it pretty well. But at the same time, you could learn. Maybe you could learn how to make a better omelet. Or especially if it's your first omelet that you're making, you're probably going to screw it up, but you will learn from that because you will understand what actions lead towards states and rewards. And anything else in life, for instance, even trading on the stock market and buying and selling and getting certain feedback from the market in the sense of return, positive or negative returns, that's also an environment, and that's you participating in that environment as an agent. Driving a car is also an environment where you can turn the steering wheel, you can accelerate, you can brake, and so on, and you're getting feedback from the environment. And one of those feedbacks is a policeman giving you a speeding fine if you're going above the acceptable or allowed speed limit on that highway. And therefore, from there, you learn that, okay, that's not something that should be done because it leads to a negative reward. So rewards don't have to be just at the very end of the process. They can be throughout the journey, throughout the process. So those are a couple of examples. And in terms of AI, the simplest way to think of reinforcement learning is like training a dog. When you train a dog, you give it certain commands, and if it obeys those commands, then you give it a treat. You give it like a biscuit or something. If it doesn't obey those commands, you tell it that it's a bad dog, or you just don't give it a treat. And through that process, it learns what certain commands or what it needs to do, what action it needs to take in certain states. And the states are the commands that you're giving it. And based on that, it will get certain rewards. Of course, in the world of AI, it's not that complex. You don't have to give the AI treats. You don't have to have like a bag of biscuits with you every time. You just give it a +1 or a -1. So it's a huge advantage that in the world of AI, we've created these AIs ourselves. So the rewards that we're giving them, if you think about it, this is really cool. If the rewards you're giving them, they don't actually exist. They're just a plus or a -1 or a 1 or a 0, something like that. So it's all non-existent, it's all imaginary stuff, but at the same time, it leads to great results. We can create these amazing things, these amazing artificial intelligences by just providing rewards which don't really exist, the plus and -1. It doesn't cost us anything, but at the same time, it leads to results. So very similar to real world and that example of dogs, but here the rewards are digital and just numbers. And with that in mind, we can talk about a little bit about robo dogs. I love this example. So this is just a random picture. It's not necessarily that exact robo dog, that is trained through reinforcement learning. Some robo dogs, especially the older ones, you'd have an algorithm in there. And this is actually a good example of the difference between pre-programmed agents and reinforcement learning agents. So you could have a robot dog which is pre-programmed to how to walk. It will say, so in the algorithm behind the dog, in the software, it'll say, okay, so in order to walk, you need to move your left leg forward, left front leg forward, then your back right leg forward, then your front right leg forward, then your back left leg forward, and repeat that action. And that's a definition of walking. It's a function inside this dog. And then it might have, how to sit, how to stand, and things like that. Whereas in a robot dog that is trained through reinforcement learning, what happens is you don't pre-program it. This is the key concept to everything here, that you don't have any algorithm inside that is hard-coded into the dog. Instead, you have what we'll be discussing in the future. You have this reinforcement learning algorithm, which is told that, okay, so the goal is to get from where you are now, not knowing anything, to the end of the room, for example. And here are the certain actions you can take. You can move your right foot, you can move your left foot, you can move your right back foot, your left back foot. So here are all the degrees of freedom that you can do. You can move them like this, you can move them like that. So it's like a list of actions you can take. And your rewards are every time you take a step forward, you get a +1. Every time you fall over, you get a -1. And that's all there is to it. And then they just leave the dog and let it figure it out on its own. So the dog tries to stand up, it falls, then it realizes that, okay, I shouldn't do that action that led to me falling, because every time I fall, I get a -1, which is not good for me. Then, so it does the other action that helped it stand up. And then it figures out, it just experiments, tries things randomly, and then figures out that it can make a step forward by moving its right front foot. And it gets a +1, and it realizes, oh, I should do more of that. Okay, cool. So it now learns that it should do more of this and less of that. And through this learning process, it very quickly understands how it can walk. And those dogs that figure it out on their own can actually sometimes walk better than dogs that are pre-programmed. Because when we pre-program things, we look at the real live dogs, or we use our own imagination how to do it. Whereas a reinforcement learning dog can optimize things on its own, and because it's an AI, sometimes it can get even better results. And that's how they can train these same robot dogs to play soccer. You can't train a normal dog to play soccer, because simply the whole approach is different, and it's not something that probably a normal dog has been trained to do or has ever done in its process of its evolution. Whereas reinforcement learning robot dogs can very easily understand how to play soccer, as long as you tell them what the rewards are, what the goals are, what the possible actions they can take are. So that is how reinforcement learning works in general. That's a quick overview of reinforcement learning. I hope that got you very excited about what's going to come next, because it's a completely different world compared to pre-programmed solutions or hard-coded solutions where you have the if-else conditions. This is very different, and we're going to be talking more about that. In the meantime, we've got some additional reading for you. So if you'd like to have some supporting materials, here's a great article which you can look into. It's called Simple Reinforcement Learning with TensorFlow. It's got 10 parts. The link is here, and you'll find the clickable link in the course resources. It's by Arthur Giuliani. It's a 2016 article. And you can follow along this course and also get additional information from that article. But bear in mind that article is with TensorFlow, whereas in this course we are using PyTorch. So different implementations, but at the same time you might pick up a few things here and there that might supplement your learning that we're going to be doing in this course. So great article to follow, even if you're not considering following it for sure. Just in case, check out that first part and see if you like it, see if you would like to read it a bit more. And then we've got specific to this tutorial about reinforcement learning, there's a paper by Richard Sutton, which is called Reinforcement Learning 1 Introduction. It's a 1998 paper, so quite old, but it's, at the same time, you can learn a bit about reinforcement learning, some of the examples like that omelet example and other examples of where reinforcement learning can be applied, and just a general overview of reinforcement learning if you are looking for some additional reading. And on that note, we're going to wrap up this tutorial. Can't wait to see you next time, and until then, enjoy AI.